This is problem number 10 on the sample test problems for test number 2. Suppose that theta is the angle in the second quadrant, pi over 2 less than or equal to theta less than or equal to pi, with sine of theta equals 2/3. Give exact values, no decimal approximations, of each of the following: cosine theta, tan theta, cosecant theta. I think as soon as we get the first one, the other two will follow. So let's see if we can figure out the first one. Although if I'm being honest, the last one is the easiest question. Maybe we start there. Cosecant, remember, is 1 over the sine. And the sine is just 2/3. So this is 1 over 2/3. And then 1 over just has the effect of flipping the answer. So 3/2, and that one is done. But the other two require some more work. So you have two choices for these. I'll show you the way that I prefer, and then I'll show you another option. Either one is okay. So first we've got an angle in the second quadrant. So I'm going to draw my axes, and I'm going to draw an angle here in the second quadrant. So this right here is my angle theta. But we always draw the triangle going from the terminal ray to the x-axis in the shortest way possible. So there's my right angle, and I'm going to put a theta with like a little hash mark up there. So it's not quite theta. Turns out that's called the reference angle for theta, but it's good enough to, say anything we want to about theta. Just about. And I know that the sine is 2/3. So let's see. If I'm in the unit circle, then the sine of theta is just the y coordinate. But I don't know that it's necessarily a unit thing. I guess I could force it to be a unit thing, but that means making it so that the y coordinate is 2/3, and the bottom number is 1. The hypotenuse is 1. For me, I'd much prefer to think of it as an opposite over hypotenuse. And so that means that the opposite of my angle is 2 and the hypotenuse is 3. The opposite side is 2, hypotenuse is 3. And in part A, we're interested in finding the cosine of the angle. And so cosine, remember, is adjacent over hypotenuse. And the hypotenuse is still 3, so all that's left to do is find the adjacent side. So let's go ahead and label this adjacent side with an x. And how do we find x? We use the Pythagorean theorem. X squared plus 2 squared equals 3 squared. Solve that, and we get x is the square root of 5. And so we're done. It turns out that the adjacent side is the square root of 5, and cosine of the angle is square root of 5/3. And if we say that, we'll get almost full credit, but it's not quite right. There should be a couple of little warning bells going off in your head, maybe. We know that we've got some mnemonic device that tells us where the different trig functions are positive. And this angle we were talking about is in the second quadrant, and in the second quadrant, only the sine function is positive, and therefore also cosecant. But that means that cosine should be negative in that quadrant, but somehow we got cosine was a positive √5/3. So what happened? Well, what happened is when I solved my Pythagorean theorem equation, and I took the square root of both sides, I forgot to put in that important symbol. It's √5, or it's negative √5. Okay, so given that I know that cosine has to be negative in that second quadrant, I better pick the negative. And then the other reason that makes sense is that if I'm literally thinking about plotting this point right here and asking myself what the x-coordinate is at that point, well, it's to the left of the origin, so the x-coordinate must be some negative number. So looking at the picture, hopefully we know, oh, x is negative out there. So pick the negative out of the plus or minus, and we've got our answer, negative √5/3. And then, so that's one way to do it. Another way to do it is to use the identity. Sine squared plus cosine squared is 1. So this is true as long as the angles in both of these are the same. All right, so sine squared of my angle. So sine of my angle was 2/3. Sine squared means you take the sine of the angle and you square it. Plus cosine squared, that's what I'm after. This one doesn't rely on the picture at all, so pretend we've done none of the stuff to the left. 2/3 squared is 4/9. That's supposed to, 4/9 plus cosine squared is 1. Cosine squared, we'll subtract the 4/9 from both sides, and we get 5/9. And then solving for cosine, you take the square root of both sides. And we get cosine theta equals, so the square root of 5/9 is the same as the square root of 5/3. And again, you got to remember the plus or minus, no matter how you do it. And we do need to think about the geometry here and recognize that in the second quadrant, cosine is negative. So in this case, cosine of theta is negative root 5/3. Okay, so that's part A. Part B, we're looking for the tangent of theta. So for me, easiest way to do this is to think of the tangent as being the opposite side divided by the adjacent side. So if we've done it the first way, then we have the picture in front of us. The opposite side to that angle is 2. The adjacent side to that angle is negative root 5. Need to have that negative. And that's our answer, negative 2 over root 5. I have no problem with radicals in the bottom. You can rationalize the denominator if you wish, but I don't need you to. If you don't have the picture in front of you, then doing opposite over adjacent is not a very natural thing to do. So maybe instead, assuming that we've done it this way, this is part B, another way to think about tangent is that it is the sine of the angle divided by the cosine of the angle. And the sine of the angle was given, that was 2/3, and cosine of angle we found right up above. If we did it the identity way, we got, well, however we did it, we got negative root 5/3. So even without the picture in front of us, we could use this version for tangent. The 3's will cancel, and again, we get negative 2 over root 5.